Hello guys, welcome to my new video and welcome to my channel medicinal pharma education. In the previous videos we have discussed about the introduction, theory, laws, instrumentation associated with the UV spectroscopy and the choice of solvent and solvent effect. In this video we are going to study about the application and the very important topic, and which is not mentioned in the syllabus, is Woodward-Fieser rules. This is very important topic which is not mentioned in the topic, but it's very basic and easy topic. In today's class we are going to complete the UV visible spectroscopy completely. Let's go through the Woodward-Fieser rules. What is Woodward-Fieser rules? See, Woodward-Fieser rules. Woodward and Fisher are both are scientists. By studying various absorption spectrum of large number of compounds, they gave a conclusion that this structure can contain this much of it can absorb this much of the wavelength. By this concept they have developed the Woodward-Fieser rules. Let's go into that. See, Woodward gave certain rules for correlating lambda max with molecular structure. Since he studied UV absorption spectra of large number of compounds, I already said he studied large number of compounds, and he studied the UV absorption spectra. So he can give a structure. He can give a structure and tell that this structure contain this much nanometer. And based upon this concept, he developed the Woodward rules. And later on, these rules are modified by Scott and Fisher because of more experimental data. These two scientists conducted more experiments on the UV absorption spectra and modified the Woodward-Fieser rules. Then the name came Woodward-Fieser rules. Modified rules is known as Woodward-Fieser rules. The main application, what are the application? Why we use the Woodward-Fieser rule? The main application of it for calculating the lambda max. This is the main application, important one. Calculating the lambda max in conjugated dienes, trienes, polyenes, and alpha beta unsaturated carboxylic compounds. By using the rules, we can study all these compounds lambda max. Okay, I think so you have understood the basic concept. The basic concept is finding the lambda max without using the instrument, by using the equation. See, you can understand it very easily. I'll explain it to you in very understandable language. Woodward-Fieser rules for calculating the lambda max in conjugated dienes and trienes and polyenes. See, before considering the rules for dienes, trienes, we could be useful to discuss some terms involved in the rules. See, first, before going to the rules and the formula, we should know that some terms. Example: homoannular diene, heteroannular diene, endocyclic double bond, and exocyclic double bond. What are the terms? What are the values for this? First, homoannular diene. Homoannular diene, it is a cyclic diene having conjugated double bond in the same ring. You can see in the structure, the conjugated double bond is present in the same ring. It is homoannular. Homo means same, annular means same ring. That is a homoannular diene. Next, heteroannular diene. The name only tells that hetero, it is present in the different ring. It is a cyclic diene in which double bond is in conjugated are present in different rings. See, the conjugated double bond is present in the two different rings. That's the heteroannular double bond. Next, endocyclic double bond. Endo means inside. Based upon the name, double bond is present in the ring as shown in the below structure. See, double bond is present in the ring. It is endocyclic double bond. Next, what is exo? Exo means the opposite of endo. It is outside. It is a double bond in which one of the doubly bonded atom is present of a ring system. See, the double bond is present outside, or it can be in combination of endo and exo. Endo means inside, exo means outside. It's the basic terms used in the calculating the lambda max. These terms are very useful because the formula is related based upon this topic. Next, According to these rules, each type of dyes or train system having certain fixed values. See, based upon the data they Woodward and Fisher studied, they gave the fixed values for the structures at which absorption takes place. This constitutes the basic value or parent value. This is a fixed value. It is also called as basic value or parental value. The contributions made by various alkylic substitutions, ring residues, double bond, extending conjugated and polar groups such as chlorine, bromine, and OR group are added to the base value to obtain lambda max of a particular compound. You can understand both statements by this formula. See, calculation of lambda max is equals to the base value or the parent value plus sum of substitution contribution plus sum of other substitutions. Here substitutions may include the various alkyl group, ring residues, double bonds, or others like polar groups are added to the base value, and by this formula we can calculate the lambda max. I'll just give an example of I can give an example so that you can betterly understand how this concept works. See, here we can see the structure. It is 1,4 dimethyl cyclohexane hex 1,3 diene. You can see 1,4 dimethyl 1,4 dimethyl cyclohexane, because hex means 6 carbons, 1,3 1 and the third place we have double bonds, diene. That's the basic structure. See, the compound is an homoannular diene. Homoannular diene because the double bond is present in the same ring. I have already said here the structures are very important. See, homoannular diene means the double bond present in the same ring. That's the same concept we use here itself. Homoannular diene. Next, and it contains two ring residues. By this we can tell that the parent value or homoannular diene standard value is 253 nanometer. Two alkali substituents are 5 nanometer each. Then it's 10 nanometer. Then two ring residues 5 nanometer, and there are two, so it was 2 into 5 nanometer, and calculated value is this much. See, by calculating this value 256 plus 10 we get 273 nanometer. But by the instrument we observe in the UV spectrometer we observe 256 nanometer. See how much close relation it is there. By this is the concept of Woodward-Fieser rules, and I will give the table. I'll give an standard table here. I'll give the standard table. I'll just there are some certain rules, certain values for the Woodward-Fieser rule. I'll just give the table in here. I'll just edit it, or else you can find it in the internet. I'll just edit it here. You can just refer it later. And last of the UV spectroscopy are applications. Applications are very easy. Detection of the functional group, extent of conjugation in polar groups can be estimated. Extent of conjugated of polar group in polyenes can be estimated. Distinction of conjugated and non-conjugated compound, identification of unknown compounds, identification of compounds of different solvents, the compounds of different solvents, and determination of the strength of the hydrogen bond. These are the various types of applications, and you can refer any other book or internet for more applications or and simple application. By this video we will complete the concept of UV visible spectroscopy. The next we are going to study, in the next video we are going to study the IR spectroscopy. We will discuss the theory, modes of molecular vibration, sample handling, instrumentation, and Fourier transfer IR spectroscopy. In next video we are going to start with this. Thank you guys for supporting me. Please comment. If you are watching till now, please comment anything so that it may motivate me. At least some people are watching. thank you guys. Please understand, this is my like starting videos, starting lectures, so that it will be trickier for me to make a perfect video, but later on I'll make the videos perfectly. For now, please adjust, and thank you for supporting. The notes, I will just give you the notes. Forgot about it. See, you can copy the notes at the last stage. In every video I will give you the notes like this. You can just pause the video and write down notes. In after some days I will just give you the link of it, so that you can directly check the notes. Homoannular diene, next is heteroannular diene, next is the both endocyclic and exocyclic. Next, the basic concept of the lambda max, how lambda max is calculated, the lambda max formula, and the example for the lambda max calculation, and the answer for the calculation. Next, the applications. These are the applications which are basic. You can use the internet for more applications and very simpler application. Thank you guys. We will see you in the next video. Bye. Have a nice day.